Let's do some quick math. A commercial airplane can fly at 575 miles per hour. Our rockets fly into space at 26,400 miles per hour. But this asteroid breaks all records and zooms at 33,000 miles per hour. That's 43 times faster than the speed of sound. At that speed, you could cross the Atlantic Ocean in just 5 minutes. The worst part is that this thing could crash into the Earth. This is Asteroid 2021 RX-9. It's 120 feet wide. That makes it one-third the size of a football field. It was only recently discovered, and scientists were able to calculate its orbit. It's not round like most planets. It's an ellipse, like if you squeezed a donut a little bit. RX-9 begins its journey toward the center of the solar system, about 273 million miles from the Sun. It crosses the asteroid belt, then the orbit of Mars, and the orbit of Earth. It makes a circle around our star and then shoots back like a slingshot. The asteroid will move away from the Sun until the star's gravity forces it to begin its return journey. RX-9 makes one such round trip in 2.5 Earth years. Although the orbit of this asteroid intersects with that of our planet, it's not dangerous to us. The closest it'll get to Earth is 7.5 Earth-Moon distances. But there are many other asteroids in space. RX-9 could collide with them and change its trajectory. And that could put it on the list of potentially hazardous asteroids. And this thing is Asteroid 2021 NY1, and it's already on the list. It's as big as 2 Statues of Liberty, and it's moving through space at 6 miles per second. So this asteroid could take you to the Moon in just 11 hours. Its orbit is also elliptical. Its far point lies somewhere between the asteroid belt and Jupiter, at 3.9 Earth-Sun distances. The closest point of its orbit to the Sun is right near the Earth's orbit. Asteroid NY1 has passed Earth at only 4 Earth-Moon distances. It'll make a circle around the Sun and head back to its starting position. The asteroid makes a complete orbit in almost 4 Earth years. The record for the closest approach to Earth belongs to Asteroid 2020 VT4. It's a rock the size of a bus, and it flew at an altitude of 230 miles above Earth. For comparison, the International Space Station orbits our planet at 250 miles. So it literally flew over our heads in the region of the South Pacific Ocean. And we didn't even know this asteroid existed. It flew over the Earth at daytime, and we couldn't see it because of the sun's light. Scientists only learned about this asteroid 15 hours later. If it had fallen on Earth, well, let's say we could have had a very bad day. Although this asteroid was small, it was moving extremely fast. That gave it a tremendous amount of energy. But we have a shield that protects us from space rocks, our atmosphere. It's full of air particles. So when an asteroid enters our atmosphere, it begins to break against these particles because of friction. This heats up the asteroid so much that it begins to burn. This is the reason why the bottoms of our space shuttles were protected with black tiles. They could withstand temperatures up to 2,300 degrees Fahrenheit. So, if an asteroid is small, it could burn up completely in the atmosphere and turn to dust. If you look at it from Earth, it would look like a falling star. Scientists believe that any asteroid under 80 feet in diameter will burn up completely in the atmosphere and cause no harm. But an asteroid larger than 1.5 miles can do a lot of damage. And we know of such an asteroid that regularly passes by our planet. 4179 Toutatis. It's 3 1/3 miles wide, so it's bigger than Central Park in New York. And if you put this rock on scales, well, it'll show 5 + 11 zeros tons. That's heavy. The most frightening thing is that this asteroid moves in a chaotic orbit because it's constantly being affected by Earth and Jupiter. It's like the planets are playing ping pong with this giant rock. It also causes the asteroid to rotate like crazy. If you were on the surface of Toutatis, you would see that our Sun constantly rises and sets in completely different places. Because of this chaos, scientists can only predict the movement of this asteroid 50 years in advance. In 2004, it came within 4 Earth-Moon distances from our planet. Fortunately, there's a chance that one day it'll leave our solar system. Jupiter or Earth will launch it into distant space like a slingshot. But if it did fall to Earth, it would cause gigantic tsunamis and earthquakes all over the planet. Then the existence of our civilization would be in question. A similar catastrophe happened about 66 million years ago. At that time, I wasn't around then, but I heard about it. An asteroid the size of Manhattan flew toward Earth. The sun heated its surface and vaporized the material from it. The dust and steam turned into a giant tail that glowed brightly in the night sky. The night before it fell, it was the brightest object in the sky, perhaps even brighter than the moon. The moment this asteroid entered Earth's atmosphere, it caused a popping noise so powerful that you could hear it on the other side of our planet. It began to burn. Small fragments began to fall from the main body of the meteorite. Some of them burned up completely in the atmosphere, but others fell to the surface. The moment of impact, the mass and speed of the meteorite gave it colossal energy of about 100 teratons in TNT equivalent. That's a big boom. All this energy turned into heat. It was literally a wall of fire that spread around the impact site and burned everything in its path. The blast wave from the touchdown circled our planet several times. It caused a tsunami with waves higher than the Empire State Building, an earthquake so strong that the ground literally cracked. After this incident, about 95% of all life on Earth ceased to exist. The meteor left behind a crater as wide as 66 Golden Gate Bridges, and it was so deep you could stick 2 Mount Everests in there. And there are still many objects in the asteroid belt behind Mars that pose a threat to Earth. Like Ceres, it's not just any asteroid, it's a dwarf planet. Although it has a mass of only 1% of that of the Moon and is as wide as Texas, yeehaw, it gravitationally affects the orbits of Earth and Mars. A collision with an asteroid of that size would simply destroy the Earth, tearing it to pieces. So, humanity must learn how to avoid colliding with dangerous asteroids. Here, we have 2 options: destroy the asteroid or make it change its trajectory and fly past Earth. Destroying a huge rock that weighs as much as an entire city is difficult, so we stick with the second option. We can send a spaceship with explosive there and then do a little boom. Only we don't have to drill a hole to plant this present inside the asteroid. The boom has to be right above the surface and pointing upwards. Then, according to the law of physics, the asteroid will shift down a little bit. Even if the asteroid moves only a few feet, on a cosmic scale, this would dramatically change its trajectory. Another option is a gravity tractor. The principle is simple. Any object that has mass also has gravity, even you. Yes, you have your own gravitational force. So our plan is to send an unmanned spacecraft to the space rock. It would just have to hover over the surface of the asteroid. Then the space rock will attract the spacecraft, but the craft's engines will resist. As a result, the asteroid itself will start pulling toward the spacecraft. Voila! Earth is saved. We can also use solar power. All we have to do is build a giant space station out of thousands of magnifying lenses and send it to the sun. When we spot a dangerous asteroid, the station will focus the sun's rays on the surface of the asteroid. The ice from its surface will begin to evaporate and move upward. The reactive force will push the asteroid down. Or deliver a giant cloak of shiny material like foil to the asteroid. If you wrap the asteroid in such material, it'll reflect the sun's rays. Again, the rays are reflected one way and push the asteroid slightly the other way. This method can only work if we have a few years to spare before the asteroid arrives. Another strategy is to attach a solar sail to the asteroid. It would work like a parachute, only it won't be braking against the air, but against the sun's rays. And the simplest option? We could attach conventional rocket engines to the asteroid. Then we can not only change the trajectory of its flight, but also control it. And if a big asteroid appears on the horizon, we can use the controlled space rock as a giant ram.